Okay, here we are with Learning with Mr. Neff. This here is Algebra 1, Chapter 4.1 or 4.1 to 4.3 review. This is called Pause and Applause. And on this rainy day here, I am creating a video that hopefully will help you be ready for your quiz. So here's how it works. I give you a problem, you pause, and then afterwards you will applaud yourself because you got the correct answer. Now, of course, if you got it wrong, then I guess you can call it try and cry, but that's not real positive. So pause and applause it is. All right, we will do a little bit with 4.1 here. All right, so the Smith family took a trip from Ohio to Florida, stayed on the beach for a week, and then drove back home. Sketch a graph showing their miles traveled. Okay, so this is where you're going to do that now. Pause. And we're back. Okay, so let me show you what I came up with. All right, I want you to have a title, axes labeled. Now you don't really, I'm not sure you need to say days because we're just time and distance. We're not putting on a scale with numbers. So time and distance travel is really all you would need. And then you make a sketch. I'm trying not to go backwards, it's a little hard to sketch. But notice I have some of these here on the trip. Why is that? Oh, we took a gas break maybe, we took an eating break, and eventually arrived. Why do I have this long? It's supposed to be straight line, not going down. It is because that is when they're on vacation on the beach and they're not really traveling. Maybe they went on a trip, so you might have something in there, but it'd be very minor. Then back home, taking a few breaks, and then they're home. And there it is. And so you might even have to label that potentially on the graph what each piece is. Now let's go to the next one here. Okay, same thing. They're going from Ohio to Florida, staying on the beach, but sketch a graph showing their gas in their tank over time. Well, that's interesting. Yep, different look at it to it. So go ahead and pause. And we're back. Okay, so here is our answer. All right, now say gas, really not used, but gas in tank. So time, again, doesn't even have to say days, but time, and they go down, right? I'm driving, so I'm using it. Fill back up. And actually, you know, when I look at this now, I would probably say that I need to improve this a little bit. So I might even say something like, let me try this. So I use it slower than I fill it up. It's almost like instantly filled up, and I use it slower, and then so that would maybe be better. So some of you might be thinking, Mr. Neff, I don't think you did the good job. And some might go down here. Now, all the way. Now, if it hits here, though, that might be too far because we're maybe assuming they didn't run out of gas. But if you labeled it that way, then that would be okay. You know, we might go, but even if that happened, oh, they fill it back up quick. And then, you know, so I just realized even in my own sketch, I would probably want to pay attention to that steepness of that line, and the fill-ups would go almost straight up, and then I slowly use it over time. And even some of you are saying, well, Mr. Neff, you also probably need to have like a longer part in the middle, all right, and then go, you know, something like that on the way back. You know, and they fill up at different points as well, too. So all of those, you know, could be something like that. Now that looks like a complete mess. So sketching is a mess, and especially when you do it in pen from there. But we're going to keep going because this is recording 3, and I don't want to make any more changes. All right, here's a good one. Are these functions? Are these 4 tables functions? So go ahead and pause. And we're back here. Okay, so are they functions? Remember the definition of function is each x assigned to one y. So, yes, it is. Here, no. Next one, no. That's definitely not. Now, that one is the equation, x equals 1. That forms a vertical line, but that is not a function. That's like being in a million places at once, so that is not possible. This next one is y equals 2. That is possible, right? No change over time means change of 0 over time, like the gas tank thing. That's possible, okay? Switch back to my red. I like my red. All right, now let's get into stuff that people really get confused on. All right, types of functions. So in Algebra 1 here, we've really dealing with 5 different types. Linear, quadratic, cubic, exponential, and absolute value. And really right away, you could try and look real quick to see, is it linear, All right, and if it's absolute value, they're really close, so it probably clue you in that's one of those right away. Then ask yourself, is it exponential? Am I multiplying by the same thing every time? And then move on to quadratic and cubic. Again, looking at your second differences or third differences. So here that is -3, that's -1, that's +1, and then that's +3. But let's look at the second difference, right? 2, 2, 2, we're all positive 2. So that's the first difference, but the second difference is the same. So we know it's quadratic, we know it'll have an x squared. And then we do the same thing for the cubic as well, looking at the third difference. All right, so here we go, start off, write the rule for this one right here. So pause. And we are back. So what type is this? All right, what type of function? Well, I noticed right away, this is, I could graph this. It's +10 + 5. Well, that's a rise over run of 5. This is +5 + 1. So it's different numbers, but the ratio is the same. All right, every time. +10 + 2, and then finally +10 + 2, right? The ratio is the same every time. Make sure I did my math right. And so that's just going to be y = 5x. There's no adding or subtracting from there. I mean, it follows the form y = mx + b, and b is 0 in that case. Makes it a little bit easier. All right, let's move on to the next one. Here is your new table. So go ahead and pause. And we're back. So again, +4 + 2 + 2 + 1 + 4 + 2 + 6 + 3. What's the ratio? What's the y over the x? Oh, it is a ratio of 2. So we already know it's 2x. Okay, now it's not 2x exactly. So then we just play the game here a little bit. 2 times 2 plus something equals 5. Right? What is that, right? 2 times 4 plus something equals 9, right? What is that? And each time, now I've already figured out it's 1, right? So it's 2x plus 1. So those both were linear, okay? They're all functions that you're going to see. Just some are linear functions and some are nonlinear functions. All right, the new table here. So pause. And we are back here. Okay, now in this particular one, all right, you start looking at the difference here. So you're not adding the same thing, you're not multiplying the same thing, and you start calculating this out, right? Okay, and you look, what is that number? Mentally work. 37 is what I want to say. My brain works properly. I sure hope, because if I don't do my math right, then I'm really in trouble. And this is 6, this is 12, this is 18, and the third difference is 6, right? Oop, 6. And therefore it's cubic. And really the nice thing here is it's exactly x cubed. There's nothing added, there's nothing doubled. This is the parent function, and it's the base of it. Well, that's a little too easy, I think, for us, but making sure we know that that's where it's obviously this is in it, and then do we have to shift it from there? Okay, next one. Here we go. Now we'll turn it up a little bit. So pause. And we're back. Okay, so what are we looking at right here? Well, if you look at the second difference, you'll know that it's the same number as the second difference. So we know it has an x squared. It's going up, clues us that it's probably positive x squared. And so now we're looking at maybe is it like a 2x squared or something like that. But the thing that I want us to note is this is a big hint for us. So because we know it's x squared, we know that when we put in 0, there's a shift that occurs and increases by 3. And so the parent function really of this would be x squared right now would just be 0, 1, 4, 9, 16. If you look at all these numbers, how do I get from those numbers to the numbers I have? Well, I add 3. So if I look here, I'm going to add 3 in that right there. So y = x squared plus 3 it is. Okay, let's keep cranking them out here. I think I got 3 more on tap. All right, so pause. And we are back here looking at the problems here. Again, is it repeated addition? No. What about, second, third differences? No. Am I multiplying by the same thing? Well, if I take the second divided by the first, what do I get? Oh, right there, 1/4. Do that again. Second number, or the next number divided by the previous. So 1/16 divided by 1/4. Oh, that's 1/4. And I could keep going, right? 1/64 divided by 1/16. Oh, that's 1/4. So I have a repeated multiplier of 1/4. And there's no shifting of that. So it'd be 1/4. I really want to put it in the power to let you know that's 1/4 to the power of x, not 1 over x to over 4. But I'm 1/4 to the power of x. That's the parent function idea, or the template, is y equals a to the x. Now, could we double it or add something? Yes. And I would say of all the things, when you start having one of these and you have to double it or add to it, I think that potentially is the hardest to find. You really got to dig into it to find that. But that's not a real common thing that we've dealt with. Okay, and here's another one. 2 more, I believe. So pause. Okay, and we are back here. I want you to notice what I see right away. What happens here? +1, +1. Okay, so it has a slope of 1, but then what happens? -1, +1. -1, +1. So -1, +1 all the way through. And that clues us in that we have a slope that bounces or changes. And if you've been in class paying attention, that clues me in that it's absolute value. And so we know that we're going to have something potentially like this. You could have something else inside it, but we're not doing anything that fancy yet. We also know that it starts up at 2, and it's going downward like this. It makes upside down V. So we know there's a negative involved in it. And then also look right here. What's that clue you in on? It clues you in that there's a shift with that shape, the parent function. So the parent function flipped, but also shifted up too. And that's what is really going to clue in this. Y equals negative absolute value of x, or absolute of the absolute value of x, +2. Okay, and one more, I believe. Okay, so this one is a lot of times the way I show them to you. I show them in ordered pairs. So here they are listed. And then represent, I shouldn't have a period right there, I think. They represent a function. What is the rule? It's just like we've been doing. So I'll give you one hint, put it in the table. Okay, so you have that right there. So pause. And we are back here, okay? So in this particular one, I'm remembering which one I did. I believe, if we look at our numbers here, okay, I think I'm going to have, what is that difference? That's +2, it's -2, -6, okay, and that's enough to clue me in right there. That's -4, that's -4. Second difference the same, so I know I have an x squared. Also, I see the flip occur, right? So the flip, it's getting smaller, so we got a negative. Now remember the parent function that we have, all right? That really it should be 0, 1. Actually, this is what it is as well. This is what just x squared is. So now we know there's a negative in there, so that would make this all do this. Oh, now look. Oh, no wonder I might have had. Did I get that right? So yeah, then I times by, hopefully I get this right. Make sure I get it. -2x squared. Let's make sure that's going to work for us. It should. Okay. Got my tongue tied here. -1 squared times -2. Yes, -2. 0, yes. That's then 1. Yep. Do the same thing. Okay. So yes, that all works out good. I got tongue tied a little bit there. Okay. So I'm about up with my recording time. So that, I believe, is all I have, and that concludes all the learning with Mr. Neff. You can actually practice just going to graphing calculator like on Desmos and creating different ones and seeing what they look like and looking at the tables potentially. But anyway, that's all. Have a great day.